Alright, so this is going to be one of the practice problems from the review. I just want to give you some examples from this. I'll be doing this during this next week so you can get some examples of how to solve these. So if you're stuck and not sure what to do, you can come and look at this example, and perhaps that'll get you moving along in solving it and helping you understand it. So here you see we have this. This is problem number 23, like it says here. And we have this tennis player. I guess he's practicing tennis. He doesn't have a partner, so he has this machine that shoots the balls out at him, and then he hits them back. Okay, so he has this machine that has a 55 kilogram, pretty heavy. It's on a frictionless surface, so that's telling you you don't have to worry about friction. Don't worry about it. Don't have to calculate the force of friction or coefficient of friction or any of that. You just really have to worry about momentum. That's really what that's telling you. So it says the machine fires this mass of the tennis ball, and this is the speed of the tennis ball, and this is the direction north. And we'll probably make that positive. And really, again, you have to remember these directions are just a reminder. They don't really mean negative or positive. They just mean one direction or the other. And it wants to know what is the final velocity of the machine. So we have this machine. I don't know exactly what it looks like. Probably something got a wheel on it. Probably got like a cannon. It's got some tennis balls in here, like this, right? And then these things come flying out of there, right? And he hits them back. So we know that this is 56 kilograms, right? Or 55, I'm sorry. 55 kilograms. We know that. And we know this tennis ball is equal to 0.057 kilograms. Pretty small. They're pretty light. It's pretty normal. And then we know the velocity of this one is going to be 36 meters per second. Okay, so how do we use this information to solve for something we don't know, or to solve this final velocity of the machine? Okay, so in this problem, really what it's talking about, and the one we need to use, is the law of conservation. So I'm going to put law of conservation, C, of energy, E. So that means when we're trying to solve for the law of conservation of energy, we're going to use this one that says M1 V1 plus M2 V2. This is our initial condition. Maybe we'll label it the whole way. Initial. That equals the same thing over here, but final. So M1 V1 plus M2 V2. But this is our final. So we have to kind of ask ourselves, well, what are all these velocities and where do they go? So for this one, initially this thing is stationary. It's not moving. And initially the ball is sitting in here not moving. It's not till it gets shot out does the ball go this direction and the machine goes that direction. Okay, kind of like an elastic collision, really. So we're going to use this here, but what we need to remember is no velocity, that gets canceled. No velocity, that gets canceled, and then we just plug in over here. So this becomes 0. And really, to rewrite this equation, I'm going to erase this other stuff up here. So if we want to rewrite this thing, we really just want to know the final. Beginning, there's nothing. So it becomes 0 equals mass 1, velocity 1, and mass 2, velocity 2. Pretty easy calculation. So I'm going to get rid of this now. We just got to plug in the numbers. Okay, so we know we can just make this the machine, and we'll make this the tennis ball, TB. And this is the machine. So we have a mass, 55, And then we don't know the velocity, so 55 times v. But this other one over here we do know. The tennis ball has a mass of 0.057. Put little parentheses around that. And the velocity is 36. And it's going to be to the north, so we made that positive, right? So if we get a negative answer, we shouldn't say, oh no, I got a negative answer. We should say, oh, it just means it's going the opposite direction as north. So then if we do the math, let's get our calculator up here, and do the math. We would just go 0.057 times 36 equals that. We'll write that in now. So 55v, right, plus 2.025, or 052, sorry. And then that's equal to 0, because there's no momentum initially. So really all the momentum that's created is from this tennis ball, and in the interaction it causes the machine to go back. So then we're going to minus this from both sides. Hopefully I'll get better at writing with the mouse eventually. So then we get negative 2.052 equals 55v. And then if we want to solve for v, we divide by 55. It's going to be a really small number, but you know, it's not going to be moving that fast. You would see the machine, it wouldn't be moving very quick. So then we did the math. We'd come out with, so we just divide it by 55. And we get that small number. We'll write that out now. So the v, because it's going to cancel, right? We're going to be left with v, and we're just going to write the answer over here. But really we're just putting this calculation right over here, right? So it's 0.37. And we put the point in there, right? And then that's meters per second. It's a negative number though, right? We don't have to worry about the negative. We just need to know this one was going north, it was positive, so this is south. And that's how you do them. Pretty easy. I'm confident you can do these. If you're having trouble, just rewind this, look at it a couple times, and I'm sure these problems will become second nature to you. Let me know if you need any help with them.